We want to find the divergence of the given vector field. The divergence of the vector field is denoted using this notation here, where we often say div f, and it can be expressed as this dot product, where we have del, or the differential operator, dotted with the vector field f, where if f has an x component of p, a y component of q, and a z component of r, this dot product is equal to the sum of these partial derivatives. So it's important to recognize that the divergence of a vector field is a scalar function. Remember when we found the curl of a vector field, that gave us another vector field. Let's find the divergence of the given vector field, then we'll talk about what it means and also show it graphically. Let's write this as a dot product. We have the divergence of the vector field f is equal to the differential operator dotted with the vector field f, where the differential operator would be angle bracket partial with respect to x, comma, partial with respect to y, comma, partial with respect to z, dotted with the given vector field f. So this dot product would give us the partial derivative of 6z cosine x with respect to x plus the partial derivative of 7z sine x with respect to y plus the partial derivative of 5z with respect to z. So the sum of these partial derivatives is the same as this sum here in this formula for the divergence of the vector field f. So now let's find the partial derivatives. So the partial derivative of 6z cosine x with respect to x is negative 6z sine x plus the partial derivative of 7z sine x with respect to y would be 0 plus the partial derivative of 5z with respect to z would be 5. So the divergence of the vector field f is equal to negative 6z sine x plus 5. Now let's briefly talk about what this tells us about the vector field f. The divergence of a vector field measures the rate change inward or outward of a vector field, also called sync. So for a velocity vector field, this would represent the rate of flow inward or outward from a given point. So if the divergence is positive, the rate of change is outward, like a heated gas that is expanding. If the divergence is negative, the rate of change is inward, like a cooled gas that is being compressed. If the divergence is 0, the change is not inward or outward. The vector field is called incompressible. So to illustrate this, let's determine the divergence of the vector field f at the point 0, 0, 2, and then we'll look at this graphically. So the divergence of the vector field f at the point 0, 0, 2 would be equal to negative 6 times 2 times sine 0 plus 5. Well, sine 0 is 0, so the divergence is equal to 5. So now if we look at this graphically, the rate of change should be outward at the point 0, 0, 2. So here's the graph of the vector field f. This red point here is the point 0, 0, 2. And notice how if we pause this, let's say right here, we can see at this point the rate of change is outward, which is the reason why the divergence of the vector field f at this point is positive. I hope you found this helpful.